Okay, now finding the limit using the h method. Okay, using h. Now you see, if this is the number line, okay, and this is the point 0, okay, x tends to 0, this is 0. Now x is approaching from the right side towards 0 and from the left side towards 0. Okay, now here the function is, when it's greater than 0, it is 3x plus 1, and when it is equal and less than 0, it is 2x plus 3. Okay, now see, now as x is approaching from the right side to 0 and left and to the, from left side to 0, now you see the position of x can be said as, see, the distance from 0 to x can be assumed as h. Okay, so 0 plus h, 0 from 0 plus h will give you the distance or the position of x. Okay, this length of the h will give you the position of x. So we can write 0 plus h is equal to x. 0 plus h will give the position of x. So as x is moving towards closer and closer to 0, the length of h decreases, goes on decreasing, and it also becomes very small, that we can consider the length as 0. Okay, it becomes very slow as x is moving towards 0. The length also becomes very small, and that also becomes 0. We can assume that also becomes 0. So we can say that as x is moving towards 0, the h is also tending to 0. Okay, so as this length decreases as x is moving here. The same way from the left side, when x is moving towards 0 from the left side, and so this length marks the position of x. Okay, so and this length is, say, h. Then as x is moving, this h also decreases, keeps on decreasing, and it goes to 0 when x approaches 0. Okay, so we can assume that h is approaching 0. Okay, this length is approaching to 0. So here we can assume that the position of x is equal to 0 minus h. Okay, because this is a left hand limit, so we write it as 0 minus h, and this one as 0 plus h. Okay, now this is the h method. Now the left hand limit will be limit of the function as x is approaching 0 from the negative side is equal to limit of the function when, now instead of x we write 0 minus h. Okay, 0 minus h, and now here h is becoming smaller and smaller. Okay, going to 0, so we write h tends to 0. Limit of the function 0 minus h as h is approaching 0, which is equal to, now instead of in the function, instead of x, now you will replace it with 0 minus h. So we write it as limit as h tends to 0 to x plus 3. Okay, so now, okay, not to x plus 3, 2, instead of x we replace it with 0 minus h, 0 minus h plus 3. Okay, now when we put, now again limit h tends to 0, now we multiply 2 inside, it becomes 2 into 0 0 minus 2 into h plus 3. Now when we apply the value, put the value of h here, we get 0 minus 2 into 0 plus 3, which is equal to 0 minus 0 plus 3, which is equal to 3. Okay, in the same way, the right hand limit when it's x is approaching from the right side, okay, we write it as limit of the function as x approaches 0 from the positive side or the right side is equal to the limit of the function when x is equal to 0 plus h, when x is 0 plus h. Okay, here in the function, instead of x we put 0 plus h, and h is approaching 0. Okay, h is approaching 0, which is equal to limit h tends to 0. Now here the function is 3x plus 1. Instead of x we put x 0 plus h. Okay, so we write it as 3 0 plus h, okay, plus 1. Okay, now let's multiply 3 inside, so it becomes limit h tends to 0, 3 multiplied 0 is 0, plus 3 into h plus 3. Now when we put the value of h, the function we get it as 0 plus 3 into 0 plus 3. 0 plus 3 zeros are 0 plus 3, which is equal to 3. See, now 3 equal to 3. The LHL is 3 and RHL is 3. Okay, so here LHL equal to RHL. So we can say that limit exists at this point at x is equal to 0. Alright, okay, so we can write therefore limit exists at x tends to 0. Okay, therefore limit of the function f of x as x tends to 0 is equal to 3. Okay, now this x tends to 0 indicates both the negative and the positive because there is no symbol here, minus or plus. Okay, so this is the H method. Okay, this is how we have to solve all the remaining problems. Okay, that's it.